Today we're looking at an unusual multimeter, both in design and features. This is the FNIRSI DMT-99. It reminds me of sci-fi instruments. It even has two display themes. Switch the theme, and the look changes. It also includes features you don't usually see in multimeters of this class. On top there's a USB-C port. This bump houses the non-contact AC voltage sensor. On the back there are probe holders. Usually you carry the meter and probes in separate pockets. Here you can secure the probes. Wrap the leads around the meter, and one pocket is enough. You can also use these holders to free up your hands while measuring. They're rubberized, so the meter slides less on the table. This hole can be used to hang the meter during use or storage. There's also a stand, but the meter slides easily on the table. I'd add some rubber feet here. This opening is likely used for resetting the meter if it freezes. The display is fairly large, color, and high resolution. Viewing angles are good. Next to the display is the power button. Center button. Short press enables auto mode. Long press opens the menu. Top button. Short press activates hold mode. Long press enables rel, for relative measurements. Left button. Current measurement, MA and AC and DC. Bottom button. Temperature, frequency. Non-contact AC detection and phase detection. Right button. Voltage, AC voltage. Resistance, capacitance, diode test, and continuity. The icons make everything easy to understand. At the bottom, common input and two current inputs. For milliamps, amps, and the standard measurement input. The meter comes in a nice box. Specifications are printed on the bottom. Let's open it. Here's the meter itself. The probes are included. The wires are fairly soft. There's also a USB cable for charging. Power it on with this button. Auto mode is enabled by default. The meter selects the mode automatically. The downside is that it needs time to determine the measurement type. That's why I don't like auto mode. I prefer selecting the measurement mode manually. Press the right button. DC voltage mode turns on. Connect the probes. We'll measure voltage from a lab power supply. You can see a small offset, even with the supply turned off. I connected a second meter. The FNIRSI meter matches its readings. I set the supply to 1 volt, and both meters match. Press hold, and the reading freezes. Now I turn off the supply. The reference meter shows the voltage dropping. This meter keeps the value on screen. Press again to release hold. Long press to enter relative measurement mode. This voltage becomes the reference. As the voltage rises, the meter shows the difference from the reference. One thing to note. There's no manual range selection. Only auto ranging in all modes. Press again. And the meter switches to AC voltage mode. Let's check an outlet. Comparing the readings, the difference is only 0.2 volts. Always follow safety precautions. Press the button again and switch to resistance measurement mode. Measuring. 991 ohms. 992 ohms. This one is exactly 1 kilo ohm. Resistance measurements are fast and accurate. We can also measure capacitance. First, discharge the capacitor. Connect at 216 nanofarads. A 2% deviation is within tolerance. Now let's measure an electrolytic capacitor. Discharge it first. Connect the capacitor. The meter shows 49.6 microfarads. A slightly higher capacitance value is actually a good sign. It's worse if the value is much lower. That may indicate a dried out capacitor. Press again to switch to continuity and diode test mode. Continuity testing works pretty fast. Let's test a blue LED. The LED lights up brightly, and the meter shows 2.5 volts. If we reverse the LED, the meter displays OL, meaning it is connected with reverse polarity. Press again, and we're back to DC voltage mode. Press the left button to switch to milliamp measurement mode. I set the current to 0.5 amps. The two meters are connected in series, and show nearly identical readings. 300 milliamperes, 200 milliamperes, and here 900 milliamperes. Press the left button again, Move the leads. And now we can measure amps. 3 amps. The meter reads 3 amps with about 1% accuracy. Next are AC current ranges. For milliamps and amps. Press the bottom button to switch to temperature mode. Unfortunately, the thermocouple is not included. Press again to enter frequency mode. I'm touching the probe, and the meter shows 50 Hz. These are induced signals picked up by the probes. I connected a signal generator. Set it to 100 Hz. And the meter also reads 100 Hz. I can increase it to 200 Hz. And 300 Hz. Press again to switch to non-contact voltage detection. I bring the meter close to the monitor. It detects AC voltage and gives an audible alert. When moved away, the signal disappears. This feature lets you check whether AC voltage is present before starting repairs. I don't recommend using it for finding wires inside walls. Dedicated tools work better for that. Press again to enter live wire detection mode. Connect the lead to this terminal. Hold the meter and touch the probe. If a live wire is present, the meter alerts. Neutral wire gives no indication. You need to hold the meter for this feature to work properly. Press the center button to open the settings. The meter is currently in monitoring mode. You can switch between recording and monitoring modes. Press down to open the monitoring settings. Press again to access the stored values saved in data logging mode. Use the right button to scroll through them. Back in the menu, go to System Settings and press the left button. This changes the display theme. I'll switch it back to the original one. You can also change the language. Use the right button to adjust brightness. You can switch between Celsius and Fahrenheit. Here you can set the auto power off timer. I'll set it to 20 minutes. You can also restore the factory settings here. And view the manufacturer info and firmware version. Switch to data recording mode and hold the center button. The meter is now measuring noise. At the bottom, the minimum and maximum signal levels are shown over 30 seconds. Press the center button to save the value. Voltage monitoring is enabled now. But you can monitor almost any parameter. Milliamps, amps, temperature, frequency, DC and AC voltage, resistance, and capacitance. This mode works similarly to a data logger. But professional data loggers can save the graph itself. They also include a grid for time and signal level reference. Compared to an oscilloscope, this meter can measure more than just voltage. Here we can view the saved readings. Select monitoring mode. We can set the values we want to monitor. Here we can set minimum and maximum voltage, minimum and maximum current, and minimum and maximum temperature. Mine is set from 210 to 244 volts. Press the center button. The values we set are shown at the bottom. Since the voltage is currently 0, the left blue segment is active. I connected mains power, and now the center segment is active. If voltage goes above 244 volts, the red segment will appear. And the meter will beep. Let's take a look inside the meter. This is the inside layout. It uses a 3.7 volt, 1500 mAh battery. Here are the fuses, which can be replaced if they blow. The plastic feels solid. I'm squeezing it, and it's quite sturdy. Let's summarize. This is a very unusual and nice-looking meter. It includes the main functions needed for electricians and electronics work. The color display looks great. The interface is easy to use, and operation feels comfortable. Share your thoughts about this meter in the comments. Share this video with anyone interested in the topic. Subscribe so you don't miss future videos. Leave a like, and see you in future videos.